Ready? Good morning, people. Good morning. It's so good to see you guys. Man, it's early morning workshop, but the fact that you guys still make it out, highly respectable. Again, welcome. Hello, world. And again, thank you if I haven't said it already. I'm so glad that you guys can make it out here. Just a quick reminder before we start, the GDSC is for all majors. The Google DSC welcomes everyone of all majors, STEM major, business, arts, everyone who wants to learn. The point of the Google Developer Student Club is to um, embrace people who wants to learn because one of our mission statement is to provide learning environment for students. Quickly before we start, please make sure you guys are muted. And if you do have any questions, I believe there's the um, raise hand feature, and then the rest of the officers can help you or assist you with your questions. And lastly, be inspired. We're here to learn, we're here to grow. All right, without further ado, let's get right into it.
All right,
All
so
right.
what is programming, right? I think a lot of us kind of started off with programming in different places, right? So some of us kind of began programming, or at least heard of it first in grade school. Maybe we were lucky enough and had a lab where the teacher taught us some basic programming, or maybe we watched through we found out through movies. We watched something like The Matrix and saw the glittery green text that runs down the screen. Um, or we learned about it through video games because we enjoyed playing games like Skyrim and we wanted to learn how to make mods and we try to figure it out and it's just a little too difficult, right? So now we're in school, we're trying to learn some programming. So what is programming exactly? Um, let's go ahead and go to that slide. Programming is the
All
process
right.
of communicating with the computer using a series of symbolic instructions. So here's a quick example of what that code looks like, what those symbolic instructions look like. As you can see, it's kind of English, right? And if I were to run this, essentially it's just adding 80 plus 10 at the very bottom. And we'll go over this in a bit, kind of later on, how this all works. But 80 plus 10 equals 90, right? Um, Let's go on to the next slide. In a way, you can think of programming as though you were writing a recipe. Okay, so on the left hand side, we have kind of the ingredients, like 3 eggs, 4.5 cups of flour, 3 cups of sugar. And then on the right hand side, you have kind of like the symbolic instructions that you would feed to the computer. So integer equals eggs equals 3, flour equals 4.5, and at the bottom, we have directions. Mix ingredients in a bowl. That's what you execute, what the computer would execute, the directions. And we kind of have something similar going on the right hand side using a function, which we will go over today.
Correct.
There are many programming languages. There's PHP, there's Java, R, Python. There's a lot. However, today we're just going to go ahead and focus on C++. There's many popular C++ applications that you can use it for. Like I said, all languages have their pros and cons. For C++, some of its strengths are video game development, operating system development like Windows, Linux, stuff like that, embedded systems or robotics, and desktop software like Zoom and Word and things like that. So let's go ahead and get started with an IDE. So there are a few that we recommend that you should probably install just because we all go to Mount Sac and Visual Studio Code, Visual Studio Community. Those are some of the ones that we all typically use in our classes. So highly recommend that if you're just getting started with programming, you might want to get familiar with those. But for this workshop, we're just going to go ahead and use replit.com. It's not going to need a whole lot of setup. We're just going to go ahead and teach you how to set up an account. So to set up Replit, just follow along with go to replit.com, hit that blue button, start coding.
All right.
This will show up in the next screen to register an account, just as any other account you would register. Just go ahead and fill out your name, username, password, create account, and it's going to ask you to well, actually I think there's a slide before this. Let me go ahead and check it out. There's another option on the top left of the screen that you can click on. I guess not. I guess I probably missed that one screenshot. There is a button on the top left of your screen that should show up that says create REPL, kind of like this blue button right here. You'll click on that. Then this drop down should show up and it will give you the option to choose a language. And once you do, this should show up and you can follow along with us.
All right. So, Amira, do you want to take over this?
Yeah, I'll take this one.
All
All
right.
right. So let me. All right. So I'll share my screen. This one. All right.
Okay.
So here's the thing. Why should you even learn this C++ language, or what how come, like, is it really worth it, or what can you do with it, So here's just a demo of what you can do with C++, right? So we have this code that you guys are gonna write, or we're gonna hand it to you at the end, and this is how this program goes, right? This program is about a casino guessing, a number guessing game, right? And all you have to do is you have to make sure you're selecting this console, and then you just put your name. And then this game says, choose a number between 1 to 10. Winner gets 10 times the money bet. Wrong bet, and you lose the amount you bet. And then it says your current balance is $1,000. All right, hey, so enter an amount to bet, right? Okay, so you could just put however much you want. And then this program is going to be like guess a number between 1 to 10. I'm just going to say 8. And then, you lost. The winning number was 9. And it says if you noticed, from 1,000 took it away to 900. And then, would you like to keep playing? And you can play this game as many times as you want, And then it asks you again. It asks, enter an amount to bet. Maybe $50 this time. It's probably going to be 4. Okay, and then you are in luck. You won $50. The winning number was 4, right? And I guess pretty fun. Like, it's a little addicting, right? Because you can play this game as many times as you want, but at the end, you could just say no, and then it says thank you for playing. So if you stick around till the end, you're gonna have this code and you're gonna have this program, and you can play around with it all you want. All right. So just knowing C++, you can learn to make something like this and share it with your friends, and it's pretty cool.
All right. Thank you, Amira, for sharing. Yeah, that earlier what she was showing is an application of the game we're going to code today. So stick around to the end because we're going to be coding that. For right now, Crystal, take over.
Okay, so we're gonna look at our first C++ program, and it's just a basic hello world. So first, include, and that's basically just grabbing code from the C++ standard library and essentially injecting it into our code. But of course, there's a level of abstraction, so you can't exactly see all of it, but I mean, you don't want to anyway. So we have our main function, and that is basically the entryway into the program. And that's just the standard format. Return value int main parentheses. The parentheses are there to hold parameters, but main takes no parameters in C++. In Java, it takes like a string array, I believe. And we just print out hello world, and we're going to talk a little bit more about std_cout and std_endl in the next slide. So like I mentioned, the include IO stream is just taking C++ code and putting it into your program. You don't have to know how they're implemented. You just need to know how to use them. So we already discussed main. Okay, so curly braces. Can you go back, Nate? curly braces talk about the scope of the function. So you're going to see later on that for things like if statements or something else, or a loop, the scope is usually just one line under that. But if you're having multiple lines that are supposed to belong to something, like if your if statement executes multiple things, then you're going to need curly braces because it says everything within these braces belongs to that function, belongs to that operation or so. So yeah, we can see that everything inside the braces belongs to main. So stdcin and stdcout, they're two input-output functions. So cin is actually not present in this program, but we're going to see it later. Std just talks about the scope of the function, like where it's coming from, which is the standard library. And there's actually a way that you can not have to type std : every single time you write or use a program from the standard library, which is just using namespace std. But just because that's bad coding practice and we want to know where our functions are coming from, we usually do std : a function. So cin will take in an input and you can store that in value in a variable. We'll have more examples on that later. And cout will output something onto the screen. So like in the program that we saw, it output the string hello world onto the terminal. And then we have the stream insertion and stream instruction operator. So stream insertion is the first one, the one that where it looks like this. And it's used to write output. So it's commonly paired with stdcout. The stream extraction operator takes whatever like is out there, so like your input, and it stores it into a variable or does something with it. I'm sorry, my throat is so dry. And then stdendl, if you coded in other languages, it's essentially like system.out.print ln, I think. So it's creating a new line, but in addition to that, it's also flushing the output buffer. So it's usually good practice to end with that if you are creating a new line. If it's like you want the same one, then just don't put it in. And then semicolons, you saw, were at the end of every line of command. So that indicates that your command is over and you can segue into the next line of code, because if you don't, then it'll just kind of mash together and you're going to get a lot of errors. And it's technically called a statement terminator.
All right, thank you, Crystal. That earlier was an overview, and we're gonna go deeper with each content or concepts here in the following slides. Let's start with C++ preprocessors. So the C++ preprocessors are headers, libraries. Crystal briefly mentioned about it. In a sense, you can think of it as the C++ creators have coded a lot of code, right? And then they put it in a library so that once we include it using the statement #include IOStream, we can, in a sense, use the codes that are already coded. Yeah, the preprocessors tells the compiler about the codes that are predefined already. So how do we declare it? We begin with the #include and then the angle bracket. And as you can see here, the red ones are the different libraries that are present in the C++ programming languages, such as IOStream, the string, cstd lib, ctime. We're going to see more later during the code. Someone just joined us. Cool. Oh yeah, and do know that for libraries, they do not end in semicolon because it's not like any other C++ statements. Put an output stream. Crystal.
Okay, so this is just an expansion of what we talked about earlier with cin and cout, and with extra I guess, functionalities of them. So that the first chunk of code that we have with the cin is just showing how to input something into a variable. So if we have variable, for example, we'll name it like int num. So its type is an integer and it's named num. And we are requesting the user to put in some sort of number. Let's say if we want to determine it's even or odd. So this line would create a sort of prompt in the terminal for you to enter a numerical value, and it'll store it in input. And for the cout coding segment, it's just kind of showing you how you can combine like strings and variables to output something. So for example, if we had a variable and we'll say it's type string because it's going to be like a word, and it's called name, and let's say name is equal to like Crystal because I'm Crystal. So we're going to see it printed on the terminal as my name is Crystal, and then end line. So it'll create a new line, which means that like if you were to type something afterwards, for example, like an exclamation mark, then you would see my name is Crystal and then right under it exclamation mark. If you didn't have endl, it would be my name is Crystal exclamation mark. Does that make sense? And that's pretty much it.
All right, variable data types. Variable data types are so common, and it's probably one of the most important concepts across all programming languages. Here, we're going to talk about the 5 most commonly used variable types. There's integers, which stores integers, which is whole numbers, right? As you can see in the code fragment here, the number 5 is an integer, and we assigned it to the name mynum, which we're going to talk about naming conventions later. That's integers, right? Whole numbers. Doubles store floating point numbers. What's that? Floating point numbers, in a sense, is just decimal points, right? 19.99 is an example. 5.99. You can store 6.729, right? So integers and double differ in the decimal point, while integers only whole numbers. Double can take in decimals. Yeah, as seen in that code fragment. The next thing is char, which is short for character. It stores a single character like the letter D, N, M, K, and so on, right? And then we have string. Earlier, Crystal talked about it. String stores a text. Crystal, Nathan, right? The Google Developer Student Club, Rockford, right? See, hello. And then lastly, it's bool. So the name bool may not be very intuitive at first, but bool stores 2 values, which is true or false. And I think we're going to talk about it later even more. So yeah, the variable type bool only stores either true or false. Oh. Collins. Uh-oh. Just a quick reminder, I just received a notification from Google Meets that your call will end in 10 minutes. This is our technical difficulty. If you guys don't mind, can you please rejoin? I will post a new Google Meets link, and you guys can join there. All right, just a heads up if in case this meeting will end. Yeah, quickly, naming convention. Still the same code fragments, right? Camel casing is a practice in which the first letter is small, my is small, and then mynum, the first letter of the first word is small. The first letter of the second word will be capitalized, mynum, as you see here, my float num, right? That's a naming convention called camel case. And for const, we would use the variable type. We will use the keyword const and use all the names capital. Not shown in the code fragment here, but maybe Crystal can show it later while we're live coding it. Next.
All right, so operators and if statements. So let's look into operators. What are operators? So right here we have 4 types of operators: arithmetic, relational, logical, and assignment. The first one, the arithmetic operations, they're basically mathematical. You can see there is a plus sign, minus, divide, multiply. It's exactly as you know it in your math class. That's exactly what they do. They basically anything on the left side is left side and right side are the operands, and you can add numbers together, subtract numbers together, divide and multiply. So simple as that, right? Okay, relational operators. So what are those? So if you look at it again, like think about your math class, a greater than symbol, smaller than symbol, equal, equal. Okay, so what you might not be familiar with is the equal, equal, right? So in coding, when we say equal, equal like that, it means does equal. Like when you read it, you can say that in your head, right? It might help. So on the left side, this does equal to and whatever's on the right side, right? And then it's the same way you would think of the number on the left is greater than the number on the right, right? And then you could see at the end, it also says exclamation point equal. What does that mean, right? So that when it says that, it means basically not equal to, right? So we have equal, equal, which does equal to, and then exclamation mark equal to, which is not equal to. So it's the same idea. The number on the left does not equal to the number on the right. Okay, and then these are, you can think of them like the first one, arithmetic, we add numbers, subtract numbers, and things like that. The second one, relational, you could think of it as like comparing. Is this greater than? Is this smaller than? Think of like true and false statements because that's what they're usually used to do. And then there's logical operators. There's, what does it mean, right? Because it looks when you see it for the first time, you don't know what this is. So this is basically an and right next to it is an or, right? So that and sign, you put it 2 times, and it basically means that anything on the left and anything on the right. So think of it like this, right? We have something like the thing on the left should be true and the thing on the right should be true, right? And then when it says or, it means this one or that one. It's like it's okay if one of them is right? So if the first one's correct, then that's fine. We can end it there. So these are what the logical operators for. The assignment operators, these are more simple you know what? It goes back to the previous slide, actually, what we went over previously, right? So when we had like variables and things like that. So basically, you can assign anything on the left to anything on the right. It's always about the thing on the left and thing on the right. But basically, if you have like snow equals like int snow equals 3, right? Because it's a number. You have to make sure that whatever type is on the left is the same as on the right. So you can't do like string bear equals just the number 5, or you can't put a string on the right and an integer on the left, right? You have to make sure that they match. So one last thing about this slide, it says plus equal to, minus equal to, and times equal to. Like, what does that mean? Like, you can kind of guess what it is, but it's better to what is it really, right? So when it says plus equal to, it just means that the value of whatever's on the left. So for example, if snow stores 5, plus equal to the value on the right. So if snow on the left is 5 and on the right we have a 3, basically we add them together and then snow equals that new number, right? And it's the same with the minus. So if snow is 5 and again the right number is 3, so 5 minus 3 is 2 and snow now equals 2. It just goes like that, right? So it basically adds them together and then it equals 2. So that's for this slide, right? So next up, we have an if statement. So let's put that stuff to practice, right? Well, let's put what we just learned in practice, right? So basically, where do you even use this information? So here, you can see like there's the greater than, the smaller than. These are all like comparisons. So this is where you would use them. So it has here if, and then a conditional statement, and then it says the body, right? So anything between the parentheses, again, review, like anything between the parentheses, they all like relate to that if statement. They're all like what, like they're all connected to that if statement. So in here, basically, there's an example on the, there's two examples on the right. There is 8 is greater than 2. So if it's true, then whatever is inside that body, it's gonna, it's gonna execute. But if the condition is false, like 3 is less than 5, then what's going to happen is just going to skip it, right? Because this is not true. I'm just going to skip the whole thing, from the beginning parentheses to the end parentheses. This whole thing is getting skipped, right? So again, like let's review one last time. So what kind of things can you put inside this conditional statement that, they're going to be, is going to be true or false, right? So if you have, we talked about greater than and smaller than. So we have these examples. We also have, if you remember the and the or, if it's true and true, then it's going to execute. True and false, then skip it, right? And one last thing, right? When it has something, so it's true or false, when it says or, at least one of them is right, right? So it executes. Otherwise, it skips this whole thing. All right, one last thing, okay? If else. So we're just going to build on this a little, okay? So if, again, it works the same way, but, what does this else do? So you have another example. This is a little different so that you'd see. If whatever it is true, it's going to print high, and it's going to, skip the else. What is the else even for, right? So sometimes what you have is that if the condition is false, you still want to do something, right? You don't want to just skip it all together and like not do anything at all. So if for example, a conditional statement is true, you're going to print high. And if it's false, you're going to skip the if, but go to the else, right? So then that's all there is to it. Just then else is like, in case the if statement is false and you still want to, execute something, like you still want to print to see like, at this point of the code what's happening, that's when you use the else, right?
All right, guys, I think we should move on to the new meeting link because we only have under a minute until the Google Meets close. So I will see you guys on the other side. All right, we'll continue on with the presentation there. All right.
Okay, so what are functions? Okay, so functions are basically a specific set of instructions that you write for like a small task. Like, as said before by Nate, you learn what variables are. With functions, it's basically the other half of like the programming. So like variables keep track of information, while functions actually do stuff with that information. So as you can see here, like functions, this is a segment of block coding, which is like a very simplistic style of coding. And you can see like within that a function called onRequest do all of this. So all of these are like different instructions, like, like set this value to this, set value to that. For each item in this, do this. But yeah, so functions basically just have a very specific set of instructions to complete like a small task. Like these tasks can be something as big as like calculating a complex number using different variables of data, or just like a small function that helps another function complete something else. The big idea with functions is that they're reusable code. So like rather than like having your main function just have like all the instructions, you can have functions to like dumb it down a little bit, so it's a lot easier to read and it's a lot easier to like program, because like if you can reuse code, then that means you can like weed out all the redundancy in your program. Okay, so function main. Your main function is basically the control hub for your entire program. So when you start your program, it's gonna start at this function. Just ignore the fact that it says int. It's not really important. But with programming, your main function is basically gonna control everything in your program. So like you can design like multiple functions, have multiple values stored, but like everything's gonna come back to your main function. So your main function tells your program where to go and what to do. So like in this example snippet right here. Like, this is not a real function, obviously, but like, let's say this program is designed to like make a robot go to school, right? So in int main, you'd have a wake up function, and then you have an if statement is like, if you're still lazy, then snooze your alarm for 5 more minutes. Then you have a brush teeth function, put on clothes function, etc. So with all these functions, it's basically just to combine together to complete your entire program. So like, let's say like once the wake up function is, once the brush teeth function is finished, then your program will go refer back to the main function to see what to do next. Okay, next. Okay, function anatomy. So this is kind of important. So this is like how you design your functions in your program. So number one, we have the function type. As you can see in the code snippet at the bottom, it's integer. So this is basically what the type of value that's what Nathan discussed earlier is like what your function will return. Because functions either return a value or like an array of values, or they don't return anything at all. So like your function can either like calculate a certain number and like do this, or your function can just like complete a set of instructions like printing something, and then it will just finish. Next off, we have function name. One. Oh, come back. Yeah, next we have a function name. It's basically the name of your function you want to name it. This is like so you can refer back to it later in your main function or like whatever function is going to use that specific function. Like in this example, it's called square because it returns a square of like integer a in a parameter. So like if you want to use it in another function, you can. If you want to use it in your main, you can. It's basically to like simplify like some processes. Like instead of in your main function, instead of typing a times a, you can just call the square function with a in the parameter. And speaking of parameters, it's basically what's inside the parentheses. It's like a list of variables or just one variable if you choose, in which you can give your function some data to work with. See, like Crystal said earlier, within the closed brackets, everything in between here, like quote unquote, dies at the end of the bracket. So nothing within here lasts. So everything that the function uses has to be put into it with parameters. Okay, the code block itself, as I said, it's like everything within the brackets. This is where your function actually completes a specific task. Like in this function square, its task is to return the square of the integer a, so like the parameter a. So it creates a variable called integer variable called number or num, and then you set assign it to the value of a times a, and then it returns the value of num. And speaking of the return statement, like I said before, it returns a specific value that you designed it to. It doesn't have to specifically, but you can. Okay, next. Okay, so this is an example that we're going to use in our live coding segment later. This is called a random number generator. So like it's an integer type function called random num. It creates a winning number that is equal to all of this mess. You don't need to concern yourself with like how specifically this works, but basically it just this rand function. It's part of the CSTD library, and it takes the like it takes a it basically like gives you a random number from a certain set of values from how you design it. So like the +1 is a starting point, and the 10 minus 1 gives you the range. So yeah, it assigns a certain integer from 1 to 10 and returns a random integer of that into that variable. Okay, another example is print game rules. This is one of those examples of a function that doesn't return anything, in which it will be called void. So like certain functions will be called like integer number, something like that. Void just essentially does nothing. Does nothing but like whatever's in the code block. So if the code block says to print out the casino name guessing rules, then yeah, it'll print out using stdc out the casino name guessing rules, and just not doing return a new value.
So now we're going to talk about the different kinds of loops you might encounter. So loops are really cool because it avoids doing extra work if you use them correctly. So the example I used is if you were trying to design a program and a part of that program was printing everybody's name from a super long list. Um, the without loops, a way you could do it is to just manually do see out Nate, see out Amira, see out Josh, but nobody wants to write like that many lines of code. And if there's an extra name on the list, how are you going to deal with that? Like, are you as a programmer going to go back into your code and then like, hold on, somebody new joined, I have to write out a new line, you know? So some basic loops that we're going to see are the for loops, for each loops, while loop, and do while. So in the next slide, so for loops, it uses a counter variable, and after each turn of the loop, that variable is going to be either incremented or decremented. So for example, the variable that we often use is integer I. And usually we'll do int I equals 0, and as long as I is less than, say, 5, then we execute the body of the loop, and then we add 1 to I. We might also add another number, who knows, but usually we add 1. Another way you could do it is if like I equals 5, and after each turn of the loop, you subtract it by 1, and you keep going until I hits 0. While loops do not use the counter. So it's kind of up to you to decide which one suits your program better. While loops, they are structured as while, and they have a condition inside the bracket. So as long as that condition is true, then it'll execute. I'm sorry if you hear my dog in the background. And so, for example, while, say, while name is valid equals true, it'll keep printing out the names in the list. For each loop, we didn't discuss arrays yet, but a way you could use it is, say, array is just basically a list of like values. A way you could use it is for every element inside this like list, print it out or do something with it. And then do while loops are really similar to while, but the body actually goes in front of the condition, which means that it will execute at least one time, like always. And in the next few slides, we can see some examples of that. So this is for loop. In the, just a heads up, in every loop, the sort of like parentheses is going to be where the conditions are. So first one is initialization. That's where we would put the int I equals 0. The condition would be as long as I is less than 5. And updation would be plus I, right? Because we're adding 1 to I. And then everything inside the brackets is just what you're going to do. So if we're printing names, then we're going to do print name inside the for loop body. So next one, while loop. So as you can see, the condition is next to it. The body goes under it. And can we keep going? Yeah, and then that's the enhanced for loop. So values would be the array here, and element would be a value inside the values array. Next, and then do while, as you can see, the condition's at the bottom, the body's on top. It will always do everything within the do brackets. Okay.
All right. Cool. Thank you, Crystal. Now that we discussed some important concepts, let's move on to good coding practice. So what you're gonna see later while you're coding is Crystal's gonna code some comments to help guide you, right? What is the use of comments? Well, comments, as you can see here, is the green text. It's written by first typing in 2 slashes. What that means is that it tells the compiler to disregard this statement, and it's just for us programmers to refer what that particular line or function is doing, right? It's usually used to explain for future use. Like here in this case, what is this line of code doing? stdc out, what is your name? it prompts user for their name. And then cin name, it assigns input to variable names. So the use of comment is really, sorry, the use of comment is to as a reference throughout our code. There's two types of comments. Single line, as you can see here, just two, it's supposed to be two slashes, right? That's single line comments, and multi-line comments, which starts with slash star, write out your comments, and then star slash. Everything inside these guards or sentinels in a sense will be considered as comments, and the compiler won't execute it. So the next good coding practice is to always initialize your variable. I've included this code fragment here to show you. So we start by declaring an uninitialized variable int n, right? And then when you see out n plus 1, it's going to output an error because we never know what n is, right? Is n 5? Is n 6? The bad practice about that is you never initialize and you never assign a value, so the compiler won't know what to add n into. On the other hand, a good practice is to always initialize it. Say int n is equal to 4, and you want to add 1 to it. Now the compiler knows, oh, we're adding 1 to 4, and I shall output 5 because it's 4 plus 1. Right. Miscellaneous information.
All right, so we have a few more things that we can teach you outside of kind of the main concepts we're going over today. So a few of the things we want to explain include escape characters and strings. So that just means that when you type out a string, we have an example there in the bottom left corner in the code, like inside the main function. So for example, we have first sentence, backslash n, second sentence, backslash n. Earlier, we went over the concept of an end line, which you type in at the end of a cout statement to make a new line in the output. So if you see in the output, there's first sentence and there's a new line to start the second sentence. That's what I mean by new line. So to get that same effect, instead of using the end L, you can actually use the backslash n within the string where you want those new lines to be. There's also a few more that I included here just because these are some of the simple ones. So there's backslash, I'm sorry, help me out here. Backslash quotation marks and backslash single quotation marks. So when you have a string, they already have quotations around them. When you have quotations within them, it might help to escape them occasionally if you need to specify that, hey, this is not part of the string declaration. I just want to have this quotation mark printed out. And similarly, we also have an escaped backslash. So escaped just means, hey, I want to use this symbol. I don't want the compiler to compile this and translate this as code. I want this to be translated as a string. So we can go to the next slide. And then here we have just a quick intro to some character manipulation in C++. And actually, this is actually C functionality. So C++ builds on top of C, but this still works in C++, and it might still be useful to learn. So for example, we have a character CH in the code here, and we assigned it capital E. And the next line has a string variable. And just a really quick explanation here, what's happening to, normally you have a variable, let's say, like what we have ch equals capital E. Here we have parentheses around the 1 and 2 lower. This is called direct initialization. Basically, all we're doing here is we're saying, hey, grab that capital E and make one duplicate. That's what that one is. Make one duplicate and store it in the ch string variable. And also, in the second argument there, it says 2 lower. We are converting that to a lowercase. So this variable now, when we print it out, it's going to be a lowercase e, is how that works. And also similarly, we have a toUpper function that if you wanted to convert the case to an uppercase from a lowercase, there's also that option as well. So toLower ch is what we do to convert the case.
All right, cool. Now that we've gone over important concepts and good coding practices and miscellaneous informations, we're going to move on to our live coding session with Crystal. Writing your first C++ game, casino guessing game.cpp. This is exciting. I'll let you have the share screen control, Crystal.
Okay, give me 1 second to like set up my Replit.
You guys can code along with us. Earlier we talked about how to set up in Replit. If you guys need some time to set it up, please say it in the comments and we can go back to the slides in case you need some guidance with the Replit.
All right, can everybody see what's going on?
Yep.
All right. So we're going to make a new Replit. If you weren't here for the how to create a Replit intro, it's pretty simple. Just hop onto Replit, make an account, and then click the plus create Replit. So it's going to be in C++. We're going to name this casino guessing game. Create. So there are a few conditions that we want to meet. We actually based this game off of something we dug up online and just kind of coded like how we think it was implemented. So there are certain input outputs that we want, and I can copy and paste them in the chat right now. Actually, I'll just create a requirements.txt file. Okay, so the only thing about Replit is it can be a little bit slow. So this is the input output that we are looking for. Requirements that we want is the default bet amount, because you can't play with $0. We're going to give them 1,000 to start off with. And then if you guess the number correctly, you get 10 times the bet amount you bet, like for your money, to your fund. If not, it deducts how much you bet. That's pretty much it. Okay, so it gives you off with a starter, include IOStream and a main function. Only thing is we want to make sure we're following typical C++ syntax. So this is usually used for Java. So we're gonna write our curly braces like that. Okay, so how should we start this off? Okay. All right. So first thing we're going to do is think about what functions we want. So we notice that there is an intro and a sort of like set of rules in our requirements file. So these rules, I'm actually going to copy and paste these. Okay. And we also start off with the casino guessing game title. So we're going to do std, cout, and we're going to just print the title right now. So I did 2, 3, oh no, not underscore, 1, 2, 3, 4, 5. Casino guessing game. That's just our header. And then we want to end this line, so we'll do std endl. Close this a little bit. And we can just see that it prints out the title of the game. Now, after that, our requirements ask us to name variable. So, because we're going to be referring to the player as their name the entire game, so we're going to make string. Oh shoot, that's Java code. My name, std string name. Okay. And this is where we're going to start using the cin. So we'll do cin, we'll do the stream extraction operator name, so that we can save whatever the input is into our name. And we can see how this works with std cout. We'll just print the name. So we have casino guessing game. I didn't ask for an input prompt, but we can just put Crystal and it outputs crystal because that is the new value of name. Now we're going to do the rules, and I actually don't feel like cluttering my main function with a bunch of cout commands. So instead, I'm going to do a void function, void display rules. It takes no parameters because we don't need it. It's just a default. And we copy and pasted the rules from earlier. So let's just do a sort of header, cd cout. And we're just going to write like this is the rule section. So we'll do rules. We're going to write an endl so that everything does not get appended to the rules, like in the same line. Sorry. And then we're going to do std cout. So delete this. So that's one string. And then we're going to do a new line. Clean this up a bit. This is also a new line.
So someone in the chat requested if you can post the rules.
Yeah, okay. You can copy and paste that into your own program. Okay, so that's display rules, and if we call that from the main function, so we'll call display rules, we are actually going to get an error because the main does not recognize display rules since main comes before it. In Java, it doesn't matter where your function is relative to main, but in C++ it does. So one method people do is they either put the main at the bottom, or you write function prototypes at the top. So we'll label this section function prototypes. And we just have void display rules. You literally just include the header. And then your program knows that display rules is something that exists. So when this comes up, it'll look for this function. And we will not get an error. So let's take a look here. So we see in name, we'll call, okay. And there should not be a space here. Okay, so that's our rule section. We can, I think it's time to include a prompt for name. So we'll do std cout. Please enter your name. And I actually want this to be on the same line so that it looks a little bit cleaner. So please enter your name. See how we can enter here. And then rules. I want a new line in front of rules to make it look a little nicer. All right. Now that's the sort of like aesthetic part out of the way. Let's start coding what happens during one round of the game. So we'll name our function. We'll name it int DisplayAround. So we'll do std string. We'll take in the name because we use the name to output things. And then we're going to do an int balance. So that's the amount of money you as a player have. And we're just going to create the function scope. Okay, so let's think about the variables that we need right now. We have a name variable. We also need a balance variable, and that takes the form of an int because we're not deducting by decimal, so that is perfectly valid. We have a default value of 1,000. Is there anything else we need? Oh, okay, for now that'll do. Okay, so display round, what happens during one round? Okay, we need another function. later on, we'll deal with that later. Okay, so we'll have one integer, and that will be the winning number. And I'm just going to comment this out right now because this will create an error since we do not have like a random number function yet to get a winning number. We're going to have an integer bet amount because we have to prompt for that. We're going to initialize it to 0. And then we have an integer bet number. So that's the number that our users are guessing is the right number. Okay. So we're going to tell them their current balance, SCB, cout. Your current balance is, we're going to label it with a dollar sign. And we're going to include the balance variable. So we briefly talked about how we use the stream insertion operator to include numbers and combine them with sort of like string outputs. We're going to do an std endo and flush the output buffer. So now we're going to prompt for a bet number. So we'll do std cout a comma. We'll call the user by name. So we'll do name. Enter an amount to bet. std and oh, actually, no, we don't want endo because we want it to look nice when we enter in a value. Okay, so enter an amount to bet, and then we will use stdcn to take in that value and store it to bet amount. Cn, we'll do the stream extraction operator, which is bet and then bet amount. Oh my god, bet amount. All right. So we have our bet number. Okay, now we just need the user's guess. So we'll do std cout guess any betting number from 1 to 10. We are not going to do input validation right now, just because that will take a long time, but we might in the future. And then we want our colons. Okay. And then we're going to do another stdcn, take in our bet number. Cool. And let's just check our progress so far, just to make sure everything is working the way it's supposed to. So I'll label this bet amount. And this will be bet number. Let's run this. Okay. Please enter your name. It'll be a crystal. Choose a number between 1 to 10. Winner gets 10 times. Oh, shoot. We didn't call it from the name. Okay. So we'll call DisplayAround. We'll input name and balance. And then we also need to make it visible to our program by including the function prototype. So DisplayAround. And it takes in a parameter of string, int. And you don't actually need to include variable names for your function prototype, so this is perfectly valid syntax. Okay, and then since it's supposed to return an int, I'm just going to return a garbage value right now. So we'll do return 0. Okay. So please enter your name. We'll do crystal. Choose an amount to bet. We'll do $50. And enter any betting number between 1 to 10. We'll guess 5. All right, so that is correct. It successfully took in our inputs. Now, for the round, we have to check if the bet number was correct and decide what to do from there. So first, that means that we need to figure out how to get winning number. So the way we're going to go about this is we're going to get a random number generator. So in order to do that, this might be a little bit complicated. We're going to include C time. Did I spell it wrong? Okay, yeah, that's correct. And then we'll have a function prototype. It will return an int, and it's called random num. No parameters. Okay, so we'll have integer, random num, no parameters, and create its body. So first, random numbers do not actually exist in computer science. The way they go about doing it is by basing it off of time. So just kind of copy this code. I will include it into the chat because it's a little bit complicated. Basically, you're seeding the generator. So that's the code you're going to use. This is our seed. We'll do std srand std time 0. Okay. And that sort of starts the timer thing that we're going to use to generate random numbers. You do not want to do it in the function because every time you call it, you're going to get the same number because you're seeding from 0 every single time. Okay, so we're going to do int win num equals rand. Modulus, we'll do max minus min. So max is 10, min is 1. We'll shift it by 1 because that's our minimum value. If we wanted it from 0, we would cut it off at 10 minus 1. And then we are going to return an integer winning num. So now we can actually call random num from within the DisplayAround function. So we'll do integer winning num equals random num. So the integer that we generated in the random num function is going to get assigned to this one. Okay. Right. Now we can compare the winning num versus the user's guess. So the way we'll do this is if that number is equal to winning num, and remember we're using double equals because we're comparing values. We'll congratulate them first. So we'll do std cout, do a new line, you are in luck. You have won, and we'll tell them the amount of money that they got. So our rules previously stated that if they guess correctly, then their reward is the bet amount times 10. So we'll do, you have one bet amount times 10, and then we will end that line. Okay. And now it's time to actually include the bet amount to, include the reward to the user's balance. So we're going to take balance plus equals parentheses bet amount times 10. The parentheses may be redundant because it still follows order of operations, but just for readability and just because I like how it looks, we're going to do that. So now we have an else statement. This will execute if the if statement is not true. So in this case, the only other way it would not execute is if they guessed incorrectly. So we're going to treat it as a case for such. We're going to add a kind of like, oh, you lost message. So we'll do std count, cout, sorry, better luck next time. And then we'll end that line. So std end L. And then we deduct the balance by the amount that the user bet. So we'll do balance minus equal to bet amount. And just to clarify, plus equal is the same thing as balance equals balance plus a certain amount. Balance equals balance minus a certain amount. This is just a shorthand way to write it. We will tell them what the winning number is both times. So we don't need to code that in individually to if and else. We can take that outside. So we'll do std cout. The winning number was, winning num. Then we'll end that line. And now we will tell them their newly updated balance because it will change no matter what. Your new balance is now, the reason that we need to return an int is because if we call this function, it's not going to change this balance. This balance and this balance are not the same, even though they have the same values, just because this balance only exists in the scope of DisplayAround. So the way we're going to update the actual balance in the main function is by returning the newly updated balance from here. If you don't, then balance is going to stay at 1000 forever. So yeah, that concludes our DisplayAround function. And now we're going to start writing the loop for the game. And the kind of loop that we're going to write is a yes/no loop. So at the end of every round, we're going to ask the user, do you want to keep playing? So let's first create a condition. And my condition is going to be the Boolean value, yes or no. Yes, no. And we'll say it's, actually, no, we'll call it quit. We'll say it is false. So we'll create the body of the while loop. While quit equals false. And just to clarify, loop conditions, like it doesn't have to be this value needs to be true. It's this entire condition inside needs to be true. So is quit equal to false? Yes, which means it returns true. So while quit is false, we will continue to display around. We will get rid of this. We only want to display the rules one time at the start, which is why we have it outside the loop. We only want to ask the name one time, which is why we have it outside the loop. So that's display round. And then what else do we need to do? Okay, now we're going to ask the user at the end of the round if they want to keep playing. So we'll do a prompt std cout. Do you want to keep playing? And we'll tell them what responses we are anticipating. So we'll do yes, no. Okay. And we will take in a car value, or a char value. We'll call this one yes, no. And then we will set it as yes by default. And cars are usually denoted with a single sort of like apostrophe, whereas strings use quotations, right? I believe it's actually called like single quotations. Irrelevant. So would you like to keep playing? We're going to take in the user input and store it into the char. So yes, no, no, std cin, we'll do the stream extraction operator, yes, no. Okay, and then we are going to anticipate that the user can put either capital or lowercase versions of y and n. So the way we'll do this is we'll do to lower, yes, no, which basically just returns the lowercase version of the char, so we don't have to code cases for upper and lowercase. And now we're going to say if yes, no equals lowercase n, then we are going to assign quit is true. So then when we finish this loop and we check this condition one more time, does quit equal to false? It's not anymore. So the statement will evaluate to false and this while loop will finish. And just to clarify, we do not need brackets for this if statement because it only lasts one line. If you were to put another thing here, like, oh, if yes, then we do balance plus something, then you would need another, then you would need braces. But since we only have one command after if, it's fine. And I think that should be our entire game. So let's test this out. These are warnings, and we do not need to worry about these. Oh shoot, quit does not equal true. Quit equals true. Okay, so let's test this out. Let's enter a name. So we'll do Crystal. Choose a number between 1 to 10. So we have all the rules here. We have a current balance of 11. So we're going to enter a bet amount. I'm going to say $50. And we anticipate that if I get this correct, my balance will be added by 500. And if it's not correct, it'll be 1,000 minus 50. So enter any betting number between 1 to 10. We'll say 8. And we won $500 as expected. We added it to our balance. And yeah, that's it. Program works. So I am going to stop sharing and we can see if we have any questions.
I think you should try to see if the loop goes.
The other case?
Yeah, the other case. There we go.
Okay. So let's keep playing. We're gonna put y. Oh shoot! It did not update the current balance. Oh, okay. Yeah, we forgot to assign the value to our balance in name. Okay. So please enter your name. We'll do Crystal. We'll enter $50 again, and 7 this time. So yeah, deducts by 50. We want to keep playing so our balance stays the modified amount. And we can play one more round. We'll say do $70, enter a betting number from 1 to, we'll do 7. Yeah, and it continues to deduct. All right, so yeah.
Guess at the end we could just say N for no in case you guys want to stop, right? Okay, cool. Well, that was our live coding session. I'm glad that you guys stayed till the end and follow along because now you have a working C++ game. How cool is that, right? Take over the present. So, congratulations, you have actually completed your first C++ game, the casino guessing game, .cpp. Again, I'm so glad that you guys stuck to the end. In case you guys missed any information, we're gonna post this recording on YouTube for you guys to refer back to it. Now, if you haven't already, please join the GDSC chapter, also called as Bevy, because that is where that is where events will be posted. I can quickly show you what the GDSC looks like. So this is the bevy. This is the chapter I was talking about. Here you will see upcoming events, which is the intro to C++ today, and we're going to have another upcoming event, the Flutter, on November 27th. As you can see, these are all the previous events we have done, and if you click on them, you can access the YouTube of it on YouTube. We're going to do the same for this one. We're going to upload the YouTube video in case you guys miss any informations. Back to here. I'll give you guys 10 seconds-ish. I'm pretty sure you guys are in the Discord already. Just gonna count down from 10 to join in the chapter. 10, 9, 8, 7, 6, 5, 4, 3. Cool. And this is how we communicate with you, the Discord. And yeah, if you guys would like to take a picture of this, that's cool. And yeah, refer to the Developer Student Club, Mount Sac, and YouTube. What's next? Earlier I briefly mentioned it. We're gonna have the Intro to Flutter workshop. Please scan the QR code here because that'll take you to the GDC Bevy earlier for the Flutter workshop. There you will RSVP and get the meeting link. And yeah, that's how you guys stay in the loop for. I'll give about 10 seconds. Oh, nice. Yeah, 10 minutes. All ends in 10 minutes. How perfect, right? 10, 9, 8, 7, 6, 5, 4, 3. Cool. With that, we conclude our workshop for the Intro to C++. Thank you so much for attending. And I thank you guys, officers, for helping and yeah, making this workshop possible. With that, thank you, and I'll see you guys at the next event. All right, bye.